Hello students, today's agenda is to check homework. You will be graphing by completing the square, and you will be able to work on 11.4. So today students will be able to graph quadratic equations by completing the square. So yesterday you were able to find the vertex by using the equation x equals negative b over 2a. Then that gives you the value of x, of the point that represents the vertex. That value you replace in your original equation, quadratic equation, to find your y, and so that will be your vertex, meaning the lowest or highest point of the parabola. Today, you will be graphing or finding this vertex in a different manner. So, for example, if we have y equals x squared plus 2x minus 3, we're going to be completing the square. You saw that in Unit 10, so you might want to go back and review it if you don't remember it. But completing the square means that you look for a perfect square, and then you should have a perfect square on the last one. That will be a perfect square. However, negative 3 is not a perfect square. So that means that on this side of the equation, I put x squared plus 2x plus something, and then we bring down the negative 3. Okay, that's something, we get it by doing this in here. So in here we're gonna have what it's called the perfect square, and it comes from having a perfect square in here. So remember that we keep the same in here, it's the square root of this one. The second term of this square would be half of the middle term, which is 1 in this case. And the reason for which I'm not bringing down the y in here is because we also need to add, if we add something in here to make it a perfect square, we need to add it to the other side. So remember, we divide the middle term by 2, and so it's 1. We raise that to the second power and add it in here. So 1 times 1 is 1. If we add it on one side, then we're going to add the same thing on the other side. Okay? So basically, this is because we divide this term by 2, and that's how we get this in here. If we add the square of this one on both, that makes this the perfect square. So this comes from here. This whole thing is the same as this polynomial. However, we have this negative 3, so we need to bring it down. And in here we have y plus 1. But then we cannot have this in here, the 1, so we're going to cancel this 1. And so my y is going to be equals to x plus 1 squared, and then minus 4. So, how does this help us? Well, we are going to find the vertex, because from previous units, I don't know if you remember, that whenever we have something inside of a parenthesis being added, it moves to the opposite on x. So inside of the parenthesis, if we're adding or subtracting, it moves that many spaces. If it's plus, it's going to move to the left. If it was minus, then it would move to the right. But outside of a parenthesis, it's going to move up or down. If it's positive, it goes up. but in this case, because it's negative, it's gonna go down. So what does that mean? That on x, we're gonna have -1. And on y, it's gonna be -4. Now, I want to compare these to yesterday's lesson or the previous lesson, 11.3. So that you can see that you can get the vertex either way, okay? So let me show you. So to find the vertex of this quadratic equation, I put x is equals to -b over over 2a, and negative b is -2, negative because of the negative, and b is 2, over 2 times a, the coefficient of x squared is 1, and so it's going to be -2 over 2, okay, because 2 times 2 is 2, and so -2 divided by 2 is -1. That's the value of x right here. For y, we replace this value on the original quadratic equation and replace every x with this value. So it's going to be x squared would be -1 squared. Remember that because we're squaring it, we need to put it between parentheses, plus 2 times -1 minus 3. And so that's equals to -1 times -1, +1, plus 2 times -1 is -2. Some people get confused and they just get rid of this one, which is perfectly fine, and then minus 3. And so that gives me, if I have 1, subtract 2, that's -1, minus 3, that's -4. So as you can see, my x for the vertex, just like we did in the previous lesson, my x is -1, my y is -4. So you can decide if you want to find this vertex by completing the square. And I'm going to give you, right now it sounded a little too much, but I'm going to give you some more examples and it might get easier. Or you can just choose to use the formula to find the vertex. First, finding x, then replacing that in your original quadratic equation. Okay? Now, I'm going to do the graph, and let me see if I can have this on the side because I want to have all the information right next to us. But the sketch of this graph, I'm going to cover this one, so let me put -1 in here and -4. That's your vertex, okay? And so the sketch for this, because remember we're just sketching, we're not going to have it perfect. The sketch of this, of the graph of this equation, of this quadratic equation, it's going to be for my vertex. Remember, it's the lowest or highest point, so that's where either my little mountain starts or my little valley, that's where it opens up to, okay, from actually. So my vertex is going to be -1, -4, so -1, -4, and that's my vertex. And I'm going to look, so I look at the vertex, and another piece of information that I can look at is the y-intercept, which is -3. The y-intercept is always the last number, so it's going to be -1, -2, -3. It's right there, okay? And because this is where it opens from, that means that it's going to open up. So my point of reflection is going to be right here, okay? So it's going to open this way. And right now I don't want to focus on finding the x-intercept, so I'm not sure where it's going to meet, but I want you to focus on finding this point, the vertex, and then this is easy to locate, so find that as well, and just a reflection. Okay, let me give you another example because I know it's a lot of information. Maybe it's going to be a lot easier for the next one. Okay, so we have y equals x squared plus 4x plus 4. Perfect square, perfect square, perfect. So we have y equals, remember that we open parentheses. And so this is going to be the perfect square. Remember that for the second term in the square, the perfect square, all we have to do is get half of the middle term, which is 4, so half is 2. And we don't have anything added because we're not adding or subtracting. This is already my perfect square, which is this right here. Okay? So, for my vertex, we can say that since we're adding 2, it's going to go to the left. So my x is -2. For my y, we don't have an external number being added or subtracted, so it's not going to go down or it's not going to go up, so it's just going to stay at 0. Okay, that's my vertex. And so for my graph, look how easy it is. For my graph, this is my vertex, right? It went to the left 2 spaces, so that's why it's -2, and then it doesn't have been added or subtracted, so that's 0. And so my vertex, it's going to be -2, 0, so -2, and then 0, it's right there. That's where my graph is going to go up, open up, or it will open down. Okay, so I look at my y-intercept. That's my next point that I need to locate, and so in this case it's 4, so it's going to be 1, 2, 3, 4. And since this is where it opens, that means that it's going to open on that direction as well. So 1, 2 spaces, 1, 2 spaces on this side. If I go 2 spaces in here to go here, then I'm going to go 2 spaces and then add 4. Okay, look how easy it is to graph this parabola. Okay, or to sketch it actually. Okay, this is my vertex by completing the square, and then the y-intercept is always C, so 0 is 4, and then the point of reflection, which is exactly to the other side, the same number of spaces far. Okay. Okay, let's do another one. And this is a perfect square, but 8 is not a perfect square. And again, that's when we add the 2 lines, okay? X squared plus 4x plus something, and therefore because I'm adding something on that side, I need to add it here, plus the 8 that I already have. Going to be my new equation. And so what do I add in here? Oh yeah, I have to look at the middle term. Okay, so I open my square, I divide this by 2, and so that's +2. What I add here, this number comes from squaring this, and I add that in there and in there. Okay, in my 2 blanks, I square this, and add it in there. So it's going to be 2 times 2 is 4. And I add it on both sides to maintain that balance, that equality. And so I'm going to have y plus 4 is equals to x plus 2 all to the second power plus the 8. Remember that that 8, it's still there, okay? This is this square right here, okay? Now I'm going to subtract 4 from both sides because we need to have y by itself. And so y will be equals to x plus 2 to the second power. A minus 4 is 4, so it's going to be plus 4. So when we're adding, that means that it's going to go to the left 2 spaces. When we're adding in here, it means that it's going to go up 2 spaces. And so my vertex will be at -2 for x, +4 for y. Okay, so that's my vertex, that's my y-intercept. I'm ready to graph. And again, it's a sketch because it's not perfect, especially that I don't have graphing paper in here. I should use it. Okay, my vertex is going to be -2, 4. So -2, +4, that's my vertex. And that's where it either opens up or opens down, okay? I actually can share with you that when the coefficient of x squared is positive, then my parabola is going to open up. But when it's negative, then it's going to go down, okay? So right now, it's opening up because it's positive. So my y-intercept, this is my y-intercept, is at 8. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8. And remember, if it was -2, then -4 for the mirror or point of reflection, more or less. It's going to be a -4, +8, and that's how my parabola will open. Okay. Okay, I think I have one more example. Okay, let's see. Y equals x squared minus 49. In this case, as you can see, it's one of those special cases where we don't have a middle term, so that means that my b is 0. So it's going to be +0, basically, right? We're not adding or subtracting anything because there is no middle term that I can divide by 2. And then this -49, we're just going to put it out here. So basically, this is my -49, and x plus 0 is just x, and x squared is that x squared, okay? -49, and then the x squared is right there. So how many spaces are we moving on x? We're not moving to the left, we're not moving to the right. However, we're moving on y, we're moving down, okay? And the vertex then is going to be 0, because remember that in here it tells me where to move on x, and then -49 for y. But also, this is my y-intercept, my y-intercept, which is at negative 49. So if we think of this as 10, 10, 10, that's 30, 40, and then 49 will be around there. As you can see, my x-intercept and my y-intercept, my vertex and my y-intercept are the same. So for this case, I would need my x-intercepts to be able to graph this point. You know that it's one positive and one negative of 7, right? Because of what we learned previously. That when we have the difference of two perfect squares, we say that we have one positive and one negative. Okay, so those will be my x-intercepts, but that's how I would know the values of those x-intercepts. Okay, otherwise, if I'm basing myself only on the vertex and the y-intercept, I would not be able to graph this equation. Okay, so this is just a different way, right? A different way of finding the vertex. You can decide to choose this method or the method that you learned in the previous lesson. For the first example, I showed you how to find it in a new way by completing the square. And I also showed you how to find it as in the previous lesson, and basically you can decide which method you want to use to find the vertex. Okay, to find the vertex. So I hope you can have fun. For this lesson, there are only a couple of exercises, but I do want you to practice using the vertex so that you really feel whether you want to choose one or the other. Okay, but on the test, you have the freedom to choose. Okay, so have fun working on 11.4.